Today, we are going to discuss about the Laplace transform of standard functions. Okay, so the first function that we are going to see today is a constant, that is f of t is equal to a. All right, so now if we want to calculate the Laplace transform, then this is f of s is equal to integral 0 to infinity the given function f of t into e to the minus st dt. This is the standard equation to calculate the Laplace transform. Now we make sure that this is integral 0 to infinity f of t is a into e to the minus st dt. So this is equal to a is a constant, we'll write it outside. E to the minus st integration is e to the minus st divided by minus s. And now I need to substitute 0 to infinity to this. So this is minus of a by s into, when I put infinity to e to the power minus st, as t is infinity, e to the minus infinity, that is 0, minus, when I put 0, this becomes 1. So that means this is minus of a by s into minus 1. So that is plus a by s is the required Laplace transform. So we'll make a table, and better to write these standard functions as and when we get. Okay, so that is the first entry in our table will be the a on one side, the other side will be the Laplace transform. So Laplace transform of a is a by s. So the application could be something like this. If you have 1, the Laplace transform of 1 is 1 by s. Okay, so that's the first standard function. Then let's go to the next one. F of t is equal to e to the at. Okay, now as per the standard notation, f of s is equal to integral 0 to infinity, this is f of t into e to the minus st dt. So that means the integration has to be from 0 to infinity. This is e to the at into e to the minus st dt. This is equal to integral 0 to infinity. I'll try to write this as e to the power minus, so this is s minus a into t dt. Okay, so this is okay. I don't need the integration sign now. I can substitute, I can directly get the answer. So e to the power minus of s minus a times t whole divided by minus of s minus a should be substituting from 0 to infinity to t. Okay, so this means I will write minus of 1 divided by s minus a over here into, when you put infinity to e to the power minus s minus e into t, so this is e to the minus infinity, which is 0, minus when you put 0 to t, this becomes e to the power minus 0, which is 1. So minus of minus 1 is a plus 1, so this is 1 by s minus a is the answer. This is f of s. So that leads us to the second entry in our table. So the entry you are going to make will be like this. That is, on one side I have the function e to the at. Its Laplace transform will be 1 divided by s minus a. Okay, entry number 2. Now let us proceed. The next function, standard function, is e to the power. We wrote a plus 80, so next function will be minus 80. That is, f of t is equal to, this is e to the minus 80. So very similar to the previous example, right? We can solve this, and what we get, I'll write here. So the capital F of s comes to be 1 divided by, this is s plus a. Okay, so the next entry in your table will be e to the minus 80, will have its Laplace transform as 1 by s plus a. Right? So please try to solve this by yourself. If you have any doubt, please let me know. Okay, then let's proceed further. The next standard function is f of t is equal to, this is cos hyperbolic of at. Now we'll use a property of cos hyperbolic function. That is, any cos hyperbolic function can be written in the following fashion. This is e to the power at plus e to the power minus at whole divided by 2. So half of this function is what I'm trying to apply. Okay, so this is, let's try to find the f of s now. So f of s is equal to integral 0 to infinity the given function f of t into e to the minus st dt. Okay, but this function f of t, I'm going to write it using e to the power function. So I'll write a half outside into, so integration is nothing but, this is integral 0 to infinity, there is e to the at plus e to the minus at into e to the minus st dt. So this implies, now this is equal to half of, right? We'll split the integrals 0 to infinity. This is e to the at into e to the minus st dt plus integral 0 to infinity. This is e to the minus at e to the minus st dt. So both these integrals we already have solved in the previous two cases. So let's write the answer directly. So the first term is 1 divided by, this is s minus a, and the second term is going to be 1 divided by s plus a. So how you got that? Just refer back. So these are the two functions. E to the at is 1 by s minus a. E to the minus at will be 1 by s plus a. So just look at that. E to the at, I wrote 1 by s minus a. Wherever I have the integral e to the minus at, e to the minus st dt, we have replaced it as 1 by s plus a. So now we'll take a common denominator, that is s plus a plus s minus a whole divided by, common denominator will be s square minus a square. So this becomes plus a minus a cancels, there is 2s divided by s square minus a square into half. So this 2 and 2 will cancel. All right, so that means the required Laplace transform f of s is equal to s divided by s squared minus a squared. So that's going to be the next entry in our table. So that is cos h of at will have its Laplace transform as s divided by s squared minus a squared. All right, so this is the answer. Next one is f of t is equal to sine hyperbolic of at. Here we are going to substitute as e to the at minus of e to the power minus at whole divided by 2. So this is the substitution for sine hyperbolic function. So using this, now let us try to find its Laplace transform, that is f of s is equal to integral 0 to infinity f of t into e to the minus st dt. This is equal to half of integral 0 to infinity, this is e to the at minus e to the minus at into e to the minus st dt. So this is equal to half of, so integral 0 to infinity e to the at e to the minus st dt minus integral 0 to infinity, this is e to the minus at e to the minus st dt. So using the result which we already have obtained, I can write the first term as 1 divided by s minus a minus 1 divided by the second term will be s plus a. So fractions which indicate that we need to have a common denominator now. So that is equal to 1 by 2 into, this is s plus a minus s minus of minus is plus a whole divided by, this is s square minus a square. So here s and s cancels, this is 2a divided by 2 times s square minus a square. So 2 cancels, which gives us the Laplace transform f of s is equal to a divided by s square minus a square. So the standard function sine hyperbolic at will have its Laplace transform as a divided by s square minus a square. So that will be our next entry in the table. All right. Okay, let's go to the next question. This is f of t is equal to, this is cosine value, cos at. Okay, so let's solve this. Standard equation f of s is equal to integral 0 to infinity given function f of t into e to the minus st dt. So this is nothing but integral 0 to infinity. What is f of t? F of t is cos at into, this is e to the minus st dt. Okay, so now we try to apply a specific formula of integration. Okay, the equation is like this. If you have an integral in the following format, that is e to the at into cos bt dt, this is nothing but e to the at whole divided by a square plus b square into, this is a cos bt plus b sine bt. Okay, this is the format which we are going to use. All right, so let me highlight this, saying that we are going to use this equation. Okay, all right, this means, this implies, let's write the f of s now. So comparing this with the standard integration with our Laplace transform equation, I can say that in place of a I have minus s, and in place of b I have a. Okay, so that's the change which I need to focus when I write the equation. So f of s is equal to, this is e to the at as per the equation, but a is equal to minus s for me. So this is e to the minus st whole divided by, I have a square plus b square as per the equation, but a is minus s. So this is minus s square, which is plus s square, plus b square is a square. Okay, so just look at the colors to trace. Wherever I have a in my equation, I have minus s. Okay, and where I see a b, correct, wherever I see the b, I have a in my Laplace equation. So according to that, I'm making the changes. So this into, now a cos bt, a is equal to minus s, a cos, right, b, which is actually at in this case. So plus, instead of b I have a, this is sine of at. Now I know that this is the result of integration, so I have to substitute 0 to infinity to this. Okay, so let us substitute. So this is a constant. So 1 divided by s square plus a square is a constant. I'll take this outside. Then before I substitute, I'll write the terms once again. This is e to the minus st into, this is minus s into cos at plus a into sine at. This is what I need to substitute from 0 to infinity for. So now simply put infinity over there. You don't have to worry what happens with the t, because there is a e to the minus st. When e to the minus st is substituted t as infinity, e to the minus infinity, which is 0. So right, this constant remains. This is s square plus a square into, right. So this is, the first term is 0, I understood. When I put infinity to this, that first term is 0, 0 into anything is 0, so minus. Then now I put 0 over there, which means e to the minus 0, which is 1. Okay, I can write e to the 0 into, there is a minus s into cos 0, which is 1, and sine 0 is 0, so plus a into 0. Okay, this is what I get. So a into 0 is 0, minus s into 1 is minus s, into minus 1, so there is a plus s. So I got the answer directly. Now this is s divided by s square plus a square, which is f of s. Okay, so the next entry in our table will be a cosine function, that is cos of at, will have its Laplace transform as s by s square plus a square. All right, so this is the next entry in our table. All right, let's proceed further. The next standard function is f of t is equal to, this is sine of at. So very similar to our previous solution, we'll go ahead with the calculation of f of s, that is integral 0 to infinity f of t into e to the minus st dt. In this case, this integral is sine of at into e to the minus st dt. So we look forward for some help in terms of the standard integrals, and yes, we have a standard integral to use here. That is, if you have an integral e to the at sine bt dt, if it is in the following format, then the solution we have is e to the at all divided by a square plus b square into, this is a sine bt minus b cos bt. Okay, so let me highlight this to indicate that this is our formula that we are going to use now. So let's apply this now. So I'll use coloring just to identify that. Sine at, so here I have a b here. So, and the next part is, wherever you see a I have minus s. Okay, should substitute in the same fashion. So that means the f of s is now, this is e to the at. So instead of a I have minus s, so e to the minus st divided by a square plus b square. So a is minus s, so this is s square plus a square. Okay, into, I have a sine bt, so a is minus s, into sine of bt, b is a, that's why at, minus a into cos at. Now this has to be substituted from 0 to infinity. So what we do, I'll take out 1 by s square plus a square. Then the remaining term I'll write, that is e to the minus st into, this is minus s sine, or okay, since both the terms have negative minus, I'll take the minus also outside. This is minus 1 divided by, okay, then I'll write in the following fashion, s into sine at plus a into cos at. This needs to be substituted from 0 to infinity. Okay, so this is equal to minus 1 divided by s square plus a square. Substitute infinity to this term, I understand that this is 0. And when I put 0 here, sine 0 is 0, so I'm not going to get the first term. Okay, and I have a cos 0, so a cos 0 is a. So this is 0 minus a is minus a, minus a into minus 1 is plus a. So I'm going to get my f of s Laplace transform as this is a divided by s square plus a square. So let's make an entry in the table. That is, if I have sin at, then its Laplace transform will be a divided by s square plus a square. Okay. Now, in order to solve the cosine and the sine functions which we uh, just derived, right, we have another option. Okay, I'll tell you the idea quickly, but later on you can try to solve uh, cosine function and sine function by yourselves to get their respective Laplace transform. So answers we already have. You can verify your answers with these answers. So uh, I'll write this as a note. So instead of using these standard integrals, I can also use cos at is e to the j times at plus e to the minus j times at whole divided by 2. Okay, instead of simply using e to the at, I can use e to the j at. This whole function can be used in the standard Laplace transform equation. Instead of f of t as cos at, I can write this, multiply this by e to the minus st, and we can simplify that. In that case also, we are going to get the same answer. That is s by s square plus a square as the Laplace. Similarly, we can substitute. If you have sin at, then we can substitute this as e to the power j times at minus e to the power minus j times at whole divided by 2 times j. So here the j is equal to the complex notation, that is root of minus 1. So we can use these two as a substitution for sine and cos functions whenever we derive the standard Laplace transform of cos and sine as well. In both the cases, we are expecting the same answers that we got today by solving the standard integral. Okay, now let's proceed further. So the next uh, question is standard Laplace transform that we are going to solve now is f of t is equal to t to the n. Okay, now standard definition, f of s is equal to integral 0 to infinity the given function f of t into e to the minus st dt. So this is nothing but integral 0 to infinity f of t is t to the n into e to the minus st dt. So in order to substitute for t, let's make a simplification. So put x is equal to s times t. Wherever I see st in my equation, I'm going to put this. Okay, so dx is equal to s times dt. This implies there is a dx which I need to substitute. Dx is equal to, this is s times dt. So that implies I have a dt over there. Dt is equal to dx divided by s. Okay, now t varies from, t actually has a value 0. When t is equal to 0, x is also equal to 0. And when t is infinity, this implies x is also going to reach infinity. Right? Because t is equal to x by s, or x equal to st, t equal to s. So s into 0 is 0, that's why x also 0. At the same time, if you put t equal to infinity, right, x also will reach infinity. Okay, so using this substitution technique, now let's calculate the Laplace. Let's continue the Laplace. So that is f of s is equal to, now you see I'm writing the integration, but it is now with respect to x. X is equal to 0 to infinity, right? I'm going to write there is e to the minus st into t to the n was there. So t to the n, t is nothing but x by s to the n into e to the minus x into dx by s. Okay, so this is equal to, let's try to take the constant out. There is a s to the n here and another s here. So I'll just highlight that. So there is a s with the power n, there is another s with the power 1. So s to the n and s to the 1 is s to the n plus 1 in the denominator. So this is s to the n plus 1. Then x is equal to 0 to infinity. This is x to the n e to the minus x dx. Okay, now this is a very standard integral. So we already have covered the beta and gamma functions in our video lecture series. So you can note that this function, right, is nothing but this is a gamma function, gamma of n plus 1. So what happens now? So the whole function reduces to, the Laplace transform is gamma of n plus 1 divided by s to the n plus 1 is the final answer. Okay, so this means f of, okay, let's write the standard function in our table. So on the left hand side, I have t to the n. Its Laplace transform will be gamma of n plus 1 divided by s to the power n plus 1. Okay, now the next function is this one. F of t is equal to t to the n, but here n is a positive integer. N is positive integer. Okay, so we use the previous result for this, right? The previous result says that the f of s is nothing but the gamma of n plus 1 divided by this is s to the n plus 1. We already have this. Okay, but we already know something. If n is positive integer, use a property of gamma function. Gamma of n plus 1 is nothing but this is n factorial. So this means it can be reduced to n factorial whole divided by s to the n plus 1. Okay, this is a special case. Okay, so the next entry in our table will be, so this is t to the n with n as an integer value. Then the Laplace transform will be n factorial divided by s to the n plus 1. All right, so now I want you to keep the table ready with you so that we can solve the basic problems very basic problems by simply looking at the table and making a substitution. Okay, so let's quickly go through some of the standard questions here. So my question is f of t is equal to 4. From the table, I know that f of t is a, f of s will be a by s. So this is 4 by s. Okay, see that's why the table is very important and very easy for us to, it makes the problems easy for us to solve. Okay, let's go ahead. The next question is, say f of t is equal to e to the 2t. What happens to the f of s? We know that e to the at is a by s minus a. So this is not a, sorry, 1 by s minus a. My mistake. So this is 1 divided by s minus 2. All right. Similarly, the next one is f of t is equal to e to the minus 3t. What happens to the Laplace? From the table, we know that if it is e to the minus at, this is 1 by s plus a. So a is equal to 3. So this is the answer. All right. Going further, the next question is f of t is equal to, see, this is 3 into e to the, say, plus 4t. So find out. This means f of s is equal to, see, the constant you have, you can keep there as it is. This is 3 divided by s minus 4. Okay, next question is this. F of t is equal to, let's say this is 4 cos hyperbolic of 2t. All right, let's write the f of s from the table. If it is cos h a t, our substitution will be s by s square minus a square. So a is 2 here. Anyway, there is a 4 outside. We need to keep the 4 as it is. So 4, keep the 4 as it is. Cos hyperbolic will have s divided by s square minus a square. So you look at the a is 2 here. So 2 square is 4. 4s by s square minus 4 is the answer. So just refer the table, find out what's the value of a. You write, substitute that and get the answer. If there is a constant multiplier, in this case it is 4, you write that as well. All right, then next, f of t is equal to pi into, this is sine hyperbolic of pi square t. That's right, it's Laplace now. So that is f of s is equal to, there is a pi, we'll keep the pi as it is, into sine hyperbolic of at will be a by s square minus a square. So a is a pi, so this is into pi square divided by, this is a s square minus a square. So there is already pi square, this is pi square the whole square. So that is equal to pi cube divided by s square minus pi to the power 4 is the answer. Okay, so just refer the table and write down the answers. Then next function, f of t is equal to, this is 8 cos pi by 4 into t. Now what happens to its Laplace transform? So that is f of s is equal to, 8 will remain as it is, into s by s square plus a square. What is a? A is pi by 4 the whole square. Okay, so let's simplify this bit. So this is 8s divided by s square plus pi square by 4 square, so that is 16. Now I can take a common denominator here, that is 8s divided by 16s square plus pi square whole divided by 16. Okay, now this 16 goes to the numerator, so that is 16 into 8 is 128. So this is 128 into s whole divided by 16s square plus pi square is the answer. Okay, then the next function is this f of t is equal to, this is 3 times sine t by root 6. All right, so I'll write its Laplace transform as, that is f of s is equal to 3 into the, I have to write a is nothing but 1 by root 6, a divided by s square plus a square, it's 1 by 6. Okay, so we'll simplify this as, anyway, there is a 3 by root 6 whole divided by 6. I'll take as a common denominator, so this is 6 times s square plus 1 whole divided by 6. This means there is a 3 by root 6 and I am bringing the denominator to the numerator as this divided by 6s square plus 1. So root 6 cancels this as a root 6 now. So 3 root 6 needs to be calculated. Anyway, we can keep that as it is, no problem. So this is equal to 3 root 6 divided by 6s square plus 1 is the required answer. Okay, let's go further. The next question that we are going to solve is, okay, the function that is f of t is equal to, say, t to the power of 5. It's a Laplace transform. I know that if it is t to the n and n being a positive integer, right, the f of s is nothing but n factorial, that is in this case 5 factorial divided by s to the n plus 1, so s to the 5 plus 1, that is 6. So 5 factorial is 120 by s to the 6 is the answer. Okay, let's go to the next question, that is f of t is equal to, let us say this is root of t. Okay, root of t I can write it as t to the power half, indicating that this is t to the n now. Okay, so f of s should be, if it is t to the n and n is not an integer, then I need to write this is gamma of n plus 1. So n plus 1 is half plus 1, which is 3 by 2. Gamma 3 by 2 divided by s to the power n plus 1. N plus 1, n is half, so this is s to the power 3 by 2. So let us substitute now. So gamma 3 by 2 is 1 by 2 into root pi whole divided by s to the power 3 by 2. So this is nothing but root of pi whole divided by 2 times s to the power 3 by 2 is the answer.